What is radioactive? When isotopes are unstable, they emit energy in the form of radiation. There are three main types of radiation or radioactive decay depending on the isotope.
Now that I have understood what is radioactive. But sir, what are the types? Good question, Abba. Different types of radioactivity: alpha decay, beta decay, gamma decay.
Sir, what are their meanings?
I'll help with meanings, don't you worry. Alpha decay is caused when there are too many protons in a nucleus. In this case, the element will emit radiation in the form of positively charged particles called alpha particles. Beta decay is caused when there are too many neutrons in a nucleus. In this case, the element will emit radiation in the form of negatively charged particles called beta particles. Gamma decay occurs when there is too much energy in the nucleus. In this case, gamma particles with no overall charge are emitted from the element.
Now class, who can tell me how it is measured?
Sir, is it in grams?
No, Dylan. Radioactivity is measured using a unit called the Curie. It is abbreviated as C. The Curie measures how many atoms spontaneously decay each second. The Curie was named after Marie and Pierre Curie, who discovered the element radium.
There are stable and unstable isotopes. Elements can be made up of different isotopes. Isotopes are atoms with the same number of protons and electrons, but a different number of neutrons.
Sometimes isotopes are stable and happy. These are the elements that we see around us and find in nature. However, some isotopes are unstable. These isotopes are called radioactive isotopes. What are the uses of radioactive?
Radioactive isotopes have many useful applications. In medicine, for example, cobalt-60 is extensively employed as a radiation source to arrest the development of cancer.
My brother also taught me that other radioactive isotopes are used as tracers for diagnostic purposes as well as in research on metabolic processes. When a radioactive isotope is added in small amounts to comparatively large quantities of the stable element.
Good, Gina. But it behaves exactly the same as the ordinary isotope chemically. It can, however, be traced with a Geiger counter or other detection device. Iodine-131 has proved effective in treating hyperthyroidism. Another medically important radioactive isotope is carbon-14, which is used in a breath test to detect the ulcer-causing bacteria Heliobacter pylori.
Radioactive decay to other elements. When isotopes decay, they can lose some of their atomic particles, i.e. electrons and protons, and turn from one element into another.
Sometimes isotopes decay from one unstable isotope into another unstable isotope. This can happen continuously in a long radioactive chain. Radioactive chain? OK, uranium-238. As it decays, it transforms through a number of elements including thorium, radium, francium, radon, polonium, and bismuth. It finally ends up as a stable isotope as the element lead.
Why is radiation dangerous?
Radiation can alter the structure of cells in our bodies, causing mutations which can produce cancer. The more radiation a person is exposed to, the more dangerous it is. Are some radiations good?
B. Despite the risks, there are a number of good ways that science has used radiation. These include X-rays, medicine, carbon dating, energy generation, and to kill germs.
Give interesting facts about radioactivity.
Uranium in the ground can decay into radon gas, which can be very dangerous to humans. It is thought to be the second leading cause of lung cancer.
Life of carbon-14 is used in carbon dating to determine the age of fossils. Bismuth is the heaviest element with at least one stable isotope. All elements heavier than bismuth are radioactive.
Radioactivity was discovered by the scientist A.H. Becquerel in 1896.
In industry, radioactive isotopes of various kinds are used for measuring the thickness of metal or plastic sheets. Their precise thickness is indicated by the strength of the radiations that penetrate the material being inspected.
They also may be employed in place of large X-ray machines to examine manufactured metal parts for structural defects. Other significant applications include the use of radioactive isotopes as compact sources of electrical power, for example, plutonium-238 in spacecraft. In such cases, the heat produced in the decay of the radioactive isotope is converted into electricity by means of thermoelectric junction circuits or related devices.
Thank you for watching. And hoped you learned something new today.